In today's video, I want to showcase something very interesting. So, recently I've been playing around with the idea of negative logarithms. And back or in high school, we were taught that negative basis just doesn't work because things are very messy when this isn't a full number and it's not a perfect cube and things like that. Either way, I wanted to break the rules. I wanted to see if it could actually work, and wow, it, it shocked me what happened. So let's think about this. This is asking the question -2 to the power of what gives you -8? And the answer to that is simple, 3. -2 to the power of 3 is -8. And I wanted to try using the change of base formula to see if it actually works. So that's what I did. Natural log of -8 over natural log of -2 should give you 3. Okay. Natural log of -8 can be rewritten as natural log of -1 times 8. This can be further rewritten as natural log of -1 plus the natural log of 8. And we can do the same thing for the bottom portion. Natural log of -1 plus natural log of 2, which will give you 3. So now let's put this portion on top of here. We have natural log of -1 plus natural log of 8 gives you 3 times natural log of -1 plus natural log of 2. Okay. Natural log of -1. We can define it using Euler's formula. E to the I pi is equal to -1. If we take the natural log of both sides, you'll find that these cancel, and the natural log of -1 is just I pi. So let's put that in here. I pi plus natural log of 8 is equal to 3 times natural log of -1 plus 3 times natural log of 2. I pi plus natural log of 8 is equal to 3 I pi. Now, by using the logarithm property, we can put the natural log 3 above the 2. And the 2 to the power of 3 becomes 8. So we will actually have the natural log of 8. And we have natural log of 8 on both sides. We'll simply cancel them out. And we'll have 3 I pi equals I pi. And I was shocked by this. I didn't know what to think. Because if 3 equaled 1, then this world wouldn't make any sense. So I thought of ways I can disprove it, and I did. Let's think about the idea of taking the natural, not even the base, just a logarithm with a negative number. Say the natural log of -1. Now let's say this equals some value. Let's say 3. No, sorry, not 3. Let's say it equals some value x. And if we then, what was it? Sorry, if we then multiply both sides by 3, we'll find that 3 times the natural log of -1 is equal to 3x. Now, using our logarithm property, you can put this up here. So we have -1 to the power of 3, which will give you -1 still. So this doesn't change. It does not change. And this equals 3x. Now, x has to be x equals the natural log of -1. That's how we defined it. So, which means x is equal to 3x. But that means the only possible way this could make sense is if the natural log of -1 equaled 0. But then that would contradict the Euler's formula. What do you think about this? Let me know.